Hey guys, we are in Chapter 4, Section 7. We're looking at congruence and overlapping triangles. And to be honest, we've kind of been looking at this whole time, overlapping triangles that is, so it's not going to be anything too new. Our objectives here is I can identify common parts in overlapping triangles, and I can use common parts in proofs. Alright, so overlapping triangles, they may have a common side or angle, or both. You can simplify your work with overlapping triangles by separating and redrawing the triangles. So sometimes that's easier to do so you can more clearly see what's going on. So number 1 says separate and redraw the overlapping triangles, label the vertices, then determine the common side in triangle WXZ and triangle XWY. Alright, so those are the two triangles that we are trying to determine the common side in. So when I separate them and redraw them, I'm trying to redraw WXZ. Oops, I already messed it up. WXZ would be this one. And XWY would be this one. So those are the two I want to separate. So, separating it, and obviously I don't have a ruler or anything, so mine's not going to be perfect. So this is going to be WXZ, and separating from the overlapping ones, I have XWY. And labeling this one, down here this is W, this is X, and this is Y. Okay. So I separated them, I renamed my vertices accordingly, and the common side in both of them, I see that both have this common side of XW or WX. So that would be my common side that they both have. I see that in both triangles. I have an X, I have a W. And honestly, I could have seen that up here when it wrote my triangles out, when it named them, WXZ and XWY, they both have a W and an X. So that's going to be my common side. My answer will be WX. Alright, so I want you to try below. I want you to separate and redraw the overlapping triangles. I want you to label the vertices, and then identify any common sides or angles. Alright, so now we have a proof, and we want to use common parts to make it easier. So we know a few things. We know that angle ZXW, so ZXW, this angle, is congruent to angle YWX. When you see it in red, you can kind of see that. We also are given that angle ZWX, the big angle in blue, is congruent to YXW, this big angle in blue. So we have these overlapping triangles. The first thing that it might be easy if you do is to separate them. So let's go ahead and draw them out. So here's my ZXW. And then here's my XWY. And I can mark the congruencies here again. So I know ZXW, this angle, is congruent to YWX, this angle. And I know that ZWX, this angle, is congruent to YXW, this angle. Okay, so I need to prove that these segments ZW is congruent to segment YX. Alright, so you can use any proof you want to, flow proof, two-column, paragraph proof. I'm going to go ahead and do a paragraph proof. So it is given that, and now I'm just going to say everything in my given statement. So that angle ZXW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. You also should notice that both of these two triangles have the same side. They have WX and WX. So we can say that those are congruent to each other. So looking first at this triangle, if I go from W to X, I'm going from 2 arcs to 1. So this has to be congruent from X to W because it's 2 arcs to 1. So making note of that, I'm going to say segment WX is congruent to segment XW by the reflexive property of congruence. I can go ahead and draw my hash marks on my triangles, showing that that side's congruent. Now overall, I'm trying to prove that parts of the triangles are congruent, right? That this segment part is congruent to that segment part. So I know I need to prove that my triangles are congruent all around. I have enough information now to say that triangle ZWX is congruent to triangle, and I gotta be careful. Since I said Z and Z is a vertex or a vertice that doesn't have any markings, I need to start with Y. And then I went to W, which has 2, so then I'll go to X. And I went to X, which has 1, so I'll go to W. All right, sorry, school announcement. So like I said, these triangles, or the next triangle would be Y, X, W. And I know the triangles are congruent by angle, side, angle postulate. Therefore, segment ZW is congruent to segment YX because corresponding parts of congruent triangles are congruent. We just proved the two triangles are congruent, so all of their corresponding parts are. So therefore, the segments are congruent by CPCTC. All right, so you try, given, prove the following. Go ahead and separate the triangles, relabel the vertices, and try this proof out. It can be paragraph, or flow, or 2-column. All right, let's look at problem 3. So this proof, I kind of cheated. I already have the triangles drawn out for me because I have a triangle, and then I have these small triangles in here, and then I have these other triangles in here too. So I really had to separate all of these overlapping triangles to see it more clearly. So given that segment CA, which is this long segment here, is congruent to segment CE. Well, given that alone, I have an isosceles triangle. And so I know for isosceles triangles that their base angles are congruent. So I know angle E is congruent to angle A is congruent to angle E. So down here, that would be helpful because this whole triangle is this little one, and so it's still angle A. So I'm going to put that in my proof eventually. I'm just kind of talking things out here. Also, segment BA is congruent to segment DE. So this segment is congruent to this one, or this one's congruent to that one, or on the big here is here. And overall, I want to prove that segment BX is congruent to segment DX. So that's what I'm looking to prove overall. So for this proof, I'm going to do a 2-column proof. So statements and reasons. We know that we always list our given statements first. Sometimes when it gives us multiple ones, we can split it up, but I'm just going to put them all in the same statement. So segment CA is congruent to segment CE, and segment BA is congruent to segment DE. Reason, it's given. All right. From here, I want to go ahead and say that those angles are congruent because it's an isosceles triangle. So I'm just going to be specific about naming it, since A could be several angles and E could be several angles. So specifically, angle CAE is congruent to angle CEA. I could have said BAE and DEA because that's the same angle. Again, my reason here is because those opposite sides were congruent, then the opposite angles are congruent, and that's the isosceles triangle theorem that tells us that. From here, and I'm going to start kind of marking some things on here. So I'm going to mark these are congruent. I'll mark it on this big one. I also know by the given statement that BA is congruent to DE. So I can mark that on this little one. I can mark that on this little one. And then I can't really mark that the big sides are congruent without being kind of confusing. So from here, I'm going to talk about side AE. I see that in my small triangles here, those are the same sides. So I'm going to say so. I know they're congruent to each other. So segment AE is congruent. I'm going to have to go backwards here to segment EA because A I started with had an arc and E is the one that has the arc here. So AE is congruent to EA. And my reason is the reflexive property of congruence. So I know that those triangles here, these little ones, I know they're congruent. So I can say that. The little triangle BAE is congruent to triangle DEA. And I know this by side angle side. So that leads me to conclude, since those two triangles are congruent, then all parts of these two triangles are congruent. More specifically, that angle ABE, this angle up top here, which is the same angle right here, is congruent to angle EDA over here, which is this angle over here. And that's why corresponding parts of congruent triangles are congruent. So I'm going to say that angle ABE is congruent to angle EDA. Corresponding parts of congruent triangles are congruent. So I can mark that over here on my triangle. Looking at this little triangle, I also know by vertical angles that these two angles are congruent. So those two angles are angle BXA is congruent to angle DXE by vertical angles theorem. So I know that this triangle BAX is congruent to this triangle DEX by angle side. Oh my gosh, we're almost there. So triangle BAX is congruent to triangle DEX by angle side. And therefore, what we're trying to prove, that segment BX is congruent to segment DX, that's true because, again, those two triangles are congruent, so all parts of them are congruent to the corresponding parts of the other. Corresponding parts of congruent triangles are congruent, CPCTC. Awesome. Okay, so you try, here's yours. Alright, and that's it for this video. So make sure you copy down all of my notes, everyone I did, and you have tried all of yours. Alright, see you in class. Thanks.